Hi, welcome to an Arduino tutorial from Robojax. In this video, we're going to learn how we can use the DS3231 Real-Time Clock module for Arduino. We are going to display the time on the screen on serial monitor. Then we are going to display the different format of time. And then at the end, we are going to set 2 alarms and then trigger the alarm, displaying some action on the screen or turning the buzzer and LED on and off. Also, to announce that I have launched my Patreon account. The link is below if you want to support me. You can get the code for this by clicking on the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This is a module based on DS3231 from Maxim Integrated. It is a clock module. They call it real time because as soon as you power it up, the clock will start running. You can set the time, date, month, year, second, full calendar. And when the power is running, this runs. But when the power shuts off, if you have provided this battery, the battery is DS3232. It's a 3 volts. You can also put a rechargeable. This is a lithium battery. So this will keep the clock running even if you disconnect it from power. And this can be used in many applications. It works based on I2C communication. And here are a number of pins that we have. We have ground, VCC. Ground will be connected to ground. VCC, this needs 5 volts. SDA and SCL are the pins that are needed for I2C communication to set values or read the value from this chip. We have square wave output, SQW. Through the code, you can set this. The library that I've included has that option, so you can set the frequency and get the output. And this is a 32 kilohertz clock frequency that this chip is running. Also, you can get that as an output. Sometimes people need it for some reference or whatever application that you need. This comes with, on this side, it comes with 4 pins. Usually people will use these 4 pins only. So I'm going to use only these 4 pins. When the connector arrives, you can solder it in here if it is not soldered, or if you just want 4 pins, just solder 4 header pin on this side. This LED will turn on when external power is connected. Right now there is a battery, it's holding the time. If I disconnect it from power, you see that LED will turn off. It will not consume the power from the battery. As soon as you remove this, the time will be resetted, and you can set it from Arduino, which I'm going to show you next. The module without the header is 38.5 millimeter, 22.8 millimeter wide, and it has 12.4 millimeters depth. If you want to know the length with the pin headers, 44.6 millimeter is the length. If you're concerned with weight, including the battery, it weighs 8.7 grams. Here is the official Maxim Integrated web page, including the data sheet. There is the accuracy, ±2 pulse per million at 0 degrees up to 40 degrees. And it has 2 time of day alarm. And here is the most important part. Many people will ask, the active supply current. When you connect it to 5 volts or 5.5 volts, it's 300 microampere. Here is our square wave output frequency, and there are 2 register values that you set it, RS1 and RS2. Based on this value, either you can get 1 hertz, 1.024 kilohertz, and all these. And then when you set it at 1, you will get 8.192 kilohertz output. I'll provide you the link if in case you need further information. Let me explain now the wiring. If you need a schematic diagram for this, a schematic is available at my Udemy course. The link will be provided at the udemy.com below the video. This module, we have used only 4 wires, VCC ground, and then we have SDA and SCL. And SDA and SCL, SDA is A4, SCL is A5. Here, as you can see, here is SCL, the brown. From SCL is connected to the last one. SDA is connected using black wire to the A4. If you're using other devices, for example UNO Ethernet, SDA is A4, 5 is SCL, Arduino Mega, 20 is SDA, and 21 is SCL, and the Northern Duo, they have been all mentioned. I will provide you the link for this as well. Ground is connected using ground wire to the ground here in Arduino, and VCC is connected using white wire to 5 volts. And if your Arduino has SDA and SCL at this point, you can connect it there, it will work. I've spent quite some time modifying the code, testing it, recording the video, uploading it, and preparing on the code so you can easily use it. The least that you can do for me is click on the subscribe button. It's really appreciated. Thank you. Now let me explain the code. For the code, you have to first download the library. I will provide you the link as a zip file. I will give you the link. It will be from this website. You click on download, and here download the zip, or you can download it directly from robojax.com. Once you download it, and go click on sketch, include library, add .zip library. Once you click, wherever you have saved it, point it to that. Browse and find it. For example, this is one of the zip file. This is just an example. You will select the zip file that you have downloaded and click open. Once you click open, it's done. Close this Arduino IDE and reopen it. If you do not close it, you will not be able to see it in the list. Then after restarting, click on File, Examples, scroll down until you see Arduino DS3231 Master. I cannot explain everything, just click on Simple, and I will explain it to you. Wire.h, this line says that include this wire, that's for communication between Arduino and the device. Well, this is for the actual module. All the information, communication, all the protocols is written here. And from this class, we create an instance of it and we call it clock. From this class, also we create another object, we call it DT. This will be part of this library that you download. Inside the setup, we initialize a serial monitor with 9600 baud. Clock.begin initializes the clock, and here this line sets the time from your machine. Clock.setDateTime, this is taking the date, there is a comma, and then time. This is 2 underscore. If I highlight it, you will see 1, 2. Do not change it. But if you wish to set your own time, you can type manually and set it, for example, 1950, whatever you want. But this is taken from your computer. From my computer, if I change my date and time in my computer, then whatever I have, it will be set. Once you do it one time, because the module has a battery, then you don't need to run this every time. You can comment this out, so the old date and time will be set. Up to you. This code inside the loop will run continuously, so if clock.get time and date will get time and date, and we store it in this DT, and this is printing raw data, and then from DT dot, these are the properties, dt.year will print the year, dt.month, and we print a dash here, dt.day, hour, minute. This will be 2019, this will be 6, the month, today's month, and then the day, hour, minute, and second. And then we wait for 1 second and we continuously print that. So you can play with this and you can print it any way you want. Whether if you are an electrical engineer, mechatronics, software engineer, or a hobbyist or a researcher, I have a structured Arduino course on Udemy that will take you from ground up, teaching you step by step programming hardware and software, and with schematic diagram, libraries, and codes all in one place, which will help you build your robotics and other projects in no time. The link for my course is below the video. Explain the alarm, go to examples, master, and then click on alarm. Same thing, this is exactly the same. And here we set alarm. Here they disable first alarm, clock of alarm 1 false. So this is clearing previous alarm that is already set. So we say disable the alarm and then clear it. After this, we set the date and time. For this demonstration, we are setting 2014, for example, 4/25. This is the month and that's the day, and then hour, minute, and second. But like the previous example, you can leave this and actual date and time will be there. This example makes it easy for demonstration because that time is 00, and if I set it 20 seconds, it will be 20 seconds from this. Otherwise, the clock on your machine have to reach that time to trigger the alarm. And here are different examples. This is setting the alarm every second. This is for every minute. You can set it for every minute you want. Every 20 seconds in each minute. For example, here this will go match second. This was saying every second. This is match second. And here this is match minute, every 1 minute. And these are examples that are already set, but it fits with every need that you have. For example, this will fit for every 1 hour, 1 minute and 20 seconds of each hour. So you see, match minute second. Set at each day at 1 hour, 10 minutes and 30 seconds. Hour, minute, second. And here this will be at 7 and 25th day. So this means when the day is 25, it goes to hour 7, minute and second at 0. So a little fancier. This is for every Friday. So remember, Monday is 1, means the 5th day, 10 hour, 40 minutes and 30 seconds, trigger the alarm. And this is checking the alarm settings. And then when we say check alarm 1, this is a method that comes to this function, and what it does is it sets the alarm 1, and we call it an object called A1, and for alarm 2 we call it A2. And here it checks if clock is alarm 1 set. If this is true, then we get the alarm and store it in A1, and we print alarm is triggered. And then here we check clock get alarm type 1, and here is all those types that we set: minute, hour, second. This will print the text for us. And if clock alarm 2, same thing, all of this will run. And then we come to the loop. Here it gives a time and so stores it here like before I explained it. It prints the date and time continuously for us, and if alarm 1, it checks it. If it is triggered, then it prints this text. If alarm 2 is triggered, it prints this text. In my course in Udemy, I will explain this fully and will not skip any line because this video will be very long. The link for my course for Udemy will be provided in the video below. And then we wait 1 second and the loop will continuously check the same thing. This code will print a simple date and time. Let me upload it. And here it prints the 2019. This is the month, and that's the day, and then hour, minute, and second. Hour is 24-hour format. Now click on File, Example, go here, and then this time select Date Format. Serial monitor, you can click on Tools, Serial Monitor, or you can press Ctrl+Shift+M, or you can click on this icon here. Now this is printing a long format, so let me pause it from here, from the lower corner. Auto scroll is disabled. Now this line prints the day, the month, year, and the date, time in 24-hour format, hour and minute and second. And this is for the long name. Here instead of 6, it also prints the name in January, February, March, and the rest is the same. Here this is 12-hour format, and then this is Polish, you can change it. Then June, and today is Tuesday, and it shows the day in a year, 161st day of year. And then the actual month has 30 days. It will tell you that one. And this is the Unix time. This is the number of seconds that has passed since 1970. I'll provide you the link if you want to know about it further. So this is a different way to display. And now let's open the example for alarm. Here, now this time select alarm. In this one, you can set the alarm as I mentioned, and it will display the alarm for you. Right now, the time have been set manually 2014. That's the day, that's the month, and day, hour, minute, and second. So from now on, this is the alarm. Here it prints and it says that alarm is in 20 seconds and in 1 minute. As you can see, this is 0, 1. And once you open the serial monitor, by the way, it resets it. You see, if I close this and open it again, it will run again. So be careful about this when you run serial monitor. Otherwise, if you do not run serial monitor, the alarm will perfectly run here, and you will see after 20, you will see that it will print alarm triggered. Alarm triggered because 20 seconds. And the next alarm is at 1 minute. So pay attention. When this reaches to 1 minute, alarm will be triggered. I will modify this code after the second alarm, so the buzzer can buzz. So this way you know better that alarm have been triggered. And in the same way, you can run it to turn on a light via relay, or a timer that opens the door or something, or locks the door based on some time. So this is now 52. As soon as this digit becomes 1, you will see the second alarm triggered. Now, based on the time and date that we set, you see second alarm triggered. I'm going to demonstrate the alarm feature. When the alarm is triggered, actually the buzzer will buzz, and also the LED will lit. This is for alarm 1. Alarm will run for a few seconds and will turn on, and then for alarm 2 there is a green LED, and this alarm will beep few times and will turn off. For the wiring explanation and wiring diagram of this, you can visit my course at udemy.com. The link is below the video. And here is the code with the alarm that I have changed it so you can control a buzzer. Everything is the same except these two lines. I've defined alarm 1 pin number 2, and for alarm 2 pin number 3, you can change it if you wish to use other pins. But now these two variables are available, and here using pin mode, alarm pin 1 as an output, we are setting the pin. This is pin 2 and this is pin 3. We set them as an output, and this portion is done. The rest is the same when we are going inside the loop. Here, this is the loop. Inside the loop, alarm 1 triggered. Below this line, I've written digital write alarm 1 pin high. This means turn the pin 2 high, so the buzzer will turn on, and we wait for 3 seconds. It will buzz and then turn it off. This means the low mean turn it off. And that was for alarm 1. For alarm 2 here, after this line, I've added alarm pin 2 high 100 milliseconds and then turn it off using the low command. Wait for 300 milliseconds, turn it on, and then off, and then on. So this makes beep, 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 and after that it exits. The last one is low, so the buzzer will turn off. This is a demonstration of this alarm. I'm turning it on and opening the serial monitor. So in 20 seconds, this is the buzzer 1, and the light will turn on, and it's for 3 seconds it will turn off. So pay attention to this number. And then this is the alarm 2. It will beep few times, and the light also will run now. So 3 seconds, that was turned off. Now as soon as this turns 1, you will see the beep and the light, and that's it. So you can do whatever you want with the alarm. Thank you for watching. This was how to use the DS3231 Real-Time Clock module using it with Arduino. If you learned something and like this video, please thumb up. If you have comment or question, post it at the comment section below. I try to answer and reply. And do not forget to subscribe.